Okay, the last thing I want to talk about is kinetic energy and temperature, and we always need to move our temperature into Kelvin. That's going to be very important. You need to remember, if you didn't from earlier this year, you need to memorize the formula, the Kelvin. To find the Kelvin temperature, add 273 to the Celsius temperature. Okay, so at any given temperature, all particles do not have the same exact kinetic energy. Instead, we say they exhibit a range of kinetic energies. So because they have a range of kinetic energies, we have to refer to the average kinetic energy. Similar to a class test, not everyone gets the same score. There's a range of scores on the test, so you would refer to the average score on the test. We're going to talk next about this, this illustration here. Um, I see that I'm missing some words on my screen that you have on yours. But how we're going to read this here, the blue line is a cold temperature. And you notice the average kinetic energy is lower than at the hot temperature, has a larger kinetic energy. So as you increase the temperature, you increase the average speed of the particles. That increases the average kinetic energy, which in turn also increases the spread or the range of kinetic energies. So if you look at the blue line versus the red line, you notice the blue line is much skinnier. The range is much shorter. Most kinetic energies fall within these blue marks, where in the case of the hotter temperature, they fall within a much larger range. So not only is the range spread out, it's also got a lower max. So we also say that it increases the spread of kinetic energy or the range of kinetic energies. One thing I want to point out is if you have different, let's say I have sodium chloride that's dissolved in water, I have iron that's solid, and I have helium gas. As long as these are all at the same temperature, then they're going to have the same average kinetic energy, even though they're in the different states, the dissolved in a liquid, solid, or a gas. It doesn't matter what state they're in. What's more important is the temperature. And in this case, the temperature is the same, so the kinetic energy average has to be the same. Okay, again, when we're talking about temperature, we have to put it in Kelvin. And again, that's Kelvin is just the degrees Celsius plus 273. The Kelvin, why? Because the Kelvin temperature is directly proportional to the average kinetic energy of the particles. We can't say that about Celsius because it has a negative values and positive values, and that makes proportions weird. Kelvin is an absolute scale, which we'll talk about in a minute. But as you increase the Kelvin temperature, that increases the kinetic energy. And again, it's directly proportional. So that means if the Kelvin temperature double, the kinetic energy doubles. If the Kelvin temperature is decreased by half, the kinetic energy is going to be decreased by half. So in theory, if we decrease the temperature enough, then the Kelvin temperature, the kinetic energy would decrease by down to zero. And so when the kinetic energy is zero, there would be no motion in the particles. We call that absolute zero. So again, if I decrease the temperature enough, that's going to, let's say down to whatever, the lowest of the low, that's going to make the kinetic energy zero. All motion is going to stop, and we call that absolute zero. So absolute zero is considered the lowest possible temperature. And it's also the temperature at which motion theoretically stops. Now they have never gotten, the lowest then would be 0 Kelvin. Kelvin is an absolute scale. So 0 Kelvin is equal to minus 273 degrees C. And then it can go up to whatever. There is no end in sight. We can go as hot as we want. We know the sun is thousands of degrees hot. 0 degrees C is equal to 273 Kelvin. 1 Kelvin unit of temperature is equal to 1 degree Celsius unit of temperature. The other thing to note, Celsius has a degree sign, Kelvin does not. But the labs have never actually gotten to 0 degrees Kelvin. They've gotten very, very close. They've gotten this close. So that's pretty darn close, but it's not exactly 0. That ends today's lecture. Thanks. See you on Monday. Make sure to ask questions about anything you didn't understand.